Alright, today we're going to talk about unit vectors. You may or may not have seen these before in math. Thinking back when I was in high school, whenever that was, we learned unit vectors in, I believe, Algebra 2. So you I don't know if you guys learned it then or not, but these are fairly simple. A unit vector is a vector, but it only has a magnitude of 1 and it points a certain way. So if we do a standard three-dimensional coordinate axis, we're going to do the 3D one, which always freak people out. So we still have x and y, but now we also have z. Okay, so this is negative x and negative y and negative z. Basically, a unit vector is a little vector, and it's only there to tell you which way things go. So, for instance, the one unit vector follows the x-axis, and it points in the x-axis direction, and that is called I. And we don't use a normal vector sign on top. We use I guess they call it a hat. I think it's called a hat. I always called it a caret. I don't know why, but they put a little hat there. This has a magnitude of 1, and it always points that way. So negative I would be the other way. And that's all it does. That's all it's good for. The one in the y direction is a j, 1 unit long, j, a little hat. You can put a dot there and then the hat if you want, but I don't know, all of my teachers always did, they just left the dot off and put just the hat. And then k goes in the z direction. And again, they're only there for direction. That's it. So, for instance, if I were to make a vector, let's just make some random vector here. I'm just going to call it r, some r vector. And I wrote something like, then the x component of that vector would be a number, and you'd put the little unit vector I after it, just to say like, it's this far in this direction, okay? You put the y component with the j, and you'd put the z component with the k, and that's it. So let's actually do one. Let's see. How about, I'm just gonna randomly make up some numbers here. Let's do, let's make r. Let's say it's negative, I don't know, 5 I plus 7j plus 4k. I'm just totally random on numbers. Okay, so what that means is that this vector goes negative 5 in this direction. Now since it's negative, it's the other way, so I'm not going to go way out here. Okay, I'm just going to make a little mark about there. Then 7 in the j direction. Just up here somewhere. Meh. And 4 in the k direction. Okay, so I'm going to end up like, let's see, if it was just x and y, I'd end up here, but I have to kind of pull it over this way to get the k in there. It looks something like this. This is stupid 3-dimension stuff. It makes it really tough, sorry. Okay. Another way, I could also just write it as what their components are. So in this case, the x component is negative 5. Notice I didn't put any units on this. I probably should have. Sorry. The j component, the y component is just the number attached to the j, so 7. And the z component is just the number attached to the k, so 4. That's it. So you may get some problems in here where it will give you a vector, and instead of giving you a magnitude and the angle it makes with the x-axis and say, find the components, it'll give you something like this. And it'll say, find the components. And that's super easy because all you do is just rip them off of the coefficient for these unit vectors. The x component is attached to I, the y component is attached to j, and the z component is attached to the k. And that's it. That is all you do.